All right, hi everyone. Good morning and welcome to session 3 of Vectorworks Marionette Monday. I'm Claire Masters, a member of our marketing team here at Vectorworks, and I'll be filling in for Robert Anderson this week while he's out. I'm also here with Sarah Barrett, a member of our integrated practice team and your trainer throughout our Marionette Monday training courses. We're really excited to give our users advanced training today about our new algorithmic design platform, Marionette. If you missed our first 2 training sessions, basic and intermediate, don't worry, you can just follow the links on the screen to get the recordings, or just Google Marionette Monday webinar. Today's session is part 3, and our first advanced training class for Marionette. 2 weeks from now, we'll wrap up with formal training with our second advanced class on Marionette. All these classes will be recorded and available for you to go back and listen. You'll also be notified via email once the recording from today's session is available. All right, and aside from the webinar, there are a few other avenues will be available to help. If you have any questions or are looking for specific documents, we're always available to chat on our community board at vectorworks.net/Marionette. Make sure you're joining in on the conversations on Twitter using our hashtag Marionette Monday. And most importantly, you won't want to miss out on some great Marionette courses at our upcoming Design Summit taught by your Marionette Monday trainer, Sarah Barrett. You can go to vectorworks.net/design-summit to register and see all the other fun activities we have planned in the Windy City. All right, and US attendees, you can get excited. Today's session is approved for 1 AIA-LU. Go ahead and use the link on the screen to tell us your AIA number, and we'll be sure to submit your credit. And this link will also be sent in the same recording email, so you don't have to worry about trying to write it down. And last but not least, I'd like to introduce your trainer for Marionette Monday Session 3 Advanced Training, Sarah Barrett.
Hello, everyone. Give me a moment while we switch screens. So, today in our third webinar, we're going to talk about customization, analysis, and conditional definitions. So, today we're going to be using some custom nodes. These are nodes that have been made in-house or by users and then posted on the forum. Marionette is open source, and the code of any node can be edited simply by double-clicking on the node, as you can see. All of this can be edited. The nodes we have in the library should not be thought of as the be-all and end-all of possible nodes. They are just the basics to get you started. We are always coming up with new nodes based on our user feedback and our own research. The node library is just a starting point. As we will see in the next webinar, creating your own nodes is possible, even for non-programmers. Some of the nodes that are created are just variations on existing nodes, and some are completely new commands. Some of the custom nodes we will see today will most likely be included in later releases and versions of Vectorworks, but even if they're not, they can still be used by anyone. If you are looking for custom nodes, the forum is a great place to go. I'll post the web address at the end of the webinar. On the forum, you can find answers to tricky problems and find custom nodes that might suit your needs. The great thing about Marionette is that experienced users love Marionette and love sharing their knowledge with others, so those who are on the forum are eager to help. And even if you can't find any users to help you, Marissa and I will be there. Anyone who frequents the Marionette forums is familiar with Marissa. She's an enthusiastic Marionette user and developer here at Vectorworks. In fact, the majority of the custom nodes that I'll be using today were made by her. Any node can be taken from a file and added to your own library so that it appears in the drop-down menu. So let's try it out. Let's put a new node in our library. First, we have a node that someone made in a separate file. These are some nodes that Marissa kindly made when I told her I wanted to be able to nest lists with one another. And this is what they do. You have a list here of 0 through 19, and with this chunk list node, I say I want to turn it into lists of 5 numbers each. And so 20 divided by 5 is 4. And if we look at the output, we see that we now have a list of 4 objects, and each of those objects is a list of the 5 numbers from our original list. So with that one, we also need a node to change the list back, so we have flatten list. And then another node transposes the list so that the first number in each list becomes the first list. The second number becomes the second list, as you can see here. So this may not seem useful at the moment, but I'll show you how great they are later in the webinar. So if we want to put these nodes in our library, we need to convert them into symbols. So first, let's give the nodes the colors we want, either a custom color that we made or one of the corresponding Marionette gradients. So first, we'll separate them from this network, and I like to create gradients that are similar to the original ones to use for my custom nodes because I can tell at a glance what type of node they are, but I can also tell that they aren't an original node. So these would be data flow nodes. So if I duplicate this gradient and change it a little bit, lighten up this color, and now I can just apply it to these new nodes. So now I have them looking the way I want. I need to convert them to a symbol. So go to Modify, Create Symbol, give them their name, and check Convert to Plugin Object. So now we see that our chunk list node is in our symbol library. So let's do the same for the other 2. So now we have these symbols, and now we want to put them into our Marionette library. So the way we do that is we save this file into the library user folder. And if you don't know where that is, you can go to Vectorworks Preferences, User Folders, and you'll see this address right here. If I reveal in Finder, it shows me where my user folder is. And in that library, libraries, defaults, and Marionette. So as you can see, I've already saved a couple files. These are some custom nodes, revised nodes, and other nodes that I've already put into my library. So let's save this file into that folder. And we'll call it data flow 2. So if we go back to our original file, and now when we go to the library for Marionette, you see that the data flow 2 has shown up, and there are our 3 nodes ready to be used in our drawing. As with the last webinars, once we have saved the file, as with the last webinars, the files I show can be downloaded after the webinar. So all of these nodes and definitions will be available for you to use and study in your own time. Some of these custom nodes are already available on the forum. Okay, do we remember this definition from last webinar? We used it to demonstrate debugging, but we didn't get a chance to see what it actually does. So let's run it now. And we see that it creates a sphere of slabs that, that can have a certain thickness and a certain distance between them. So to refresh our memories, let's turn this into a Marionette object. It's a prime definition for doing this. So first, we need to change the definition a little bit. The way I work with definitions, when I have more than one on a layer, I instead of having all the geometry show up at the origin, my trick is to put a locus point in the drawing and then name it, and then put in a name node and a get location, and use that as the origin point for my geometry. But if we're changing this into an object node, we do not need this. It'll automatically center on the wrapper. So we can delete these two, and we can put in 0.3 node. That's defaults are set to the origin. So now we can wrap this up. And I could turn this into an object node if I right-click on it, but first I want to save the definition inside as a symbol in case I want to change it. So let's go to Modify, Create Symbol. And then we're going to uncheck Convert to Group. And now, let's turn it into an object node. So here we have it, and we have the editable parameters on the side. I can make several copies. And I could change the parameters on each of them if I wished. So now I have the same object node, but it's been copied and changed around. But say I want to change the definition, and instead of using spheres, I want to use some other 3D object like a cone. So let's get our network back and go to Edit 2D Component. And let's change the sphere node to a cone node. So this also has another parameter that we can add in. So basically, it's the length of the cone if we want to make it different than the radius. We'll call this height, and we'll make it the default 20. And now we'll exit the symbol. And we see with now that they've been updated, all of these objects have been converted to cones, but they've kept the different parameters that we changed, as well as added this new parameter with the default value. So are there any questions at this point? When creating a 2D polygon or 3D polygon, how do you instruct what order the points are created? Well, a good way to do that is to use an ordered list node, which is in the data flow category. Actually, it's called list ordered. And so when you have your points, you can put them into the inputs of this node in the order that you want, and then you will always have the list come out in that particular order. So let's look at another definition. This definition uses the random node that we saw last webinar, as well as get and set rectangle. The get and set rectangle nodes used in this definition were edited by Marissa and now include a drop-down menu that allows us to choose an anchor point for our rectangles, just like we can with a standard rectangle in the OIP. We're also going to use Marissa's chunk list node. This definition creates a gridded wall with openings on one side that taper into random size openings on the other. So let's see what this looks like. It's a heavy script, so it always takes a few seconds to run. So this is what the pattern is. And then this is the back side of the wall with the original grid. And the front side of the wall with the random grid. So let's break down this definition a little bit. So first, we're just drawing a rectangle that will be the outline for our wall. Wall length 30 feet, wall height 10 feet. And then we are adding the rectangular grid using this definition that we used last webinar to create a grid. And if we look at it, let's delete this. And if we run this, that's what it looks like. So the next thing we're going to be doing is we're going to be randomizing the rectangles. So, and then resetting them. So now it's going to look something like this. And now for the last part, we're going to extrude the two rectangles, extrude the wall and attach the two rectangles with a loft node. So this is where the chunk list node comes into play. So right now we have two lists of rectangles that have been converted to NURBS curves, the standard rectangles and the random rectangles. And if we zip those two lists together, we get the first one, first regular rectangle, the first random rectangle, second regular rectangle, second random rectangle, and so on. And what we want to do is to create a series of lists that each have two of those rectangles in them to then loft them. So this is the chunk list. If you give it an integer of 2, it now, instead of lofting all the rectangles together, it'll loft 2 and then 2 and then 2. Taking a minute here. So that's what we get. So when using the random node, it's important to remember that every time you run the definition, the random numbers change. So in this part, I added a chance to show the random rectangles in 2D form so that they can be saved for later. And so this is what we get. So the great thing about Marionette is, oh, wait, I want to add some conditions to this. Totally forgot. So we have this wall, but we want to make sure that the random rectangles meet some sort of conditions. So, so let's add some conditions. Say that we don't want any rectangle to be more than twice as high as it is wide. If it is, then we'll flip dimensions. So we're going to be using some conditional nodes and the if node. So let's go back here. Going to get some real nodes. Going to get greater than node and the all-important if nodes. We're also going to want multiply nodes because we're going to be comparing multipliers. So if we want to make sure that we don't want any rectangle to be more than twice as high as it is wide, we can say take the height, and then we can take the width multiplied by 2. And put it into this greater node. So now, when it takes a value, if the height is greater than twice the width, this Boolean will be true, and if not, it'll be false. So what we want to do, attach this to our if node, and if it's false, we want to keep the height. But if it's true, we want to flip them. So we'll make the width the true option. Now let's move these down out of the way. Give ourselves some more room. So since we did that for the height, we also have to do it for the width. So now we're going to take this same Boolean and apply it to this if node. And so if it's false, we want the width to stay the width. And if it's true, we want the height to become the width. So now we need to disconnect these. And then this one is for our height. And this one is for our width. Oh, looks like we have more than one definition that got run. So let's run it again. As we can see, we don't have any tall rectangles. They're mostly either a standard ratio or they're very wide rectangles because we flipped all of the ones that would have been tall. So you can imagine there are lots of different conditions you can put on this. Like I could say, instead of doing that, I could say I don't want either width or height of each rectangle to be greater than 3 times its other dimension. So, and if it is, we'll bring it back to a ratio of 1 to 3. So I can do this by, if I keep this same definition and I change it to 3, but instead of flipping them, so if it's false, if it's true, then I want 3 times the width to be my height. So let's add another. And vice versa. If this is true, we want the height to be 3 times the width. So let's run it again. Okay. That did not work like it was supposed to. Oh well. I think you guys get the idea. Are there any questions at the moment? Is there a replace node with a command rather than having to rewire? At the moment, that is not something that we're capable of doing. It's definitely something that we're thinking of implementing in later versions. So, another question. After creating a network and saving it as a symbol in your personal library, is it possible to send a completed network to another computer? Yes, and that's simply by using the same principles you do in transferring symbols in Vectorworks. So as you can see, I have 3 files open right now, and if I want to get symbols from another one, I can open the other file, and there are the symbols, and all I have to do is drag them onto my file. So let's go back to our wall again without our conditions and talk about analysis. So we can find out the specs of our parawall by applying some object nodes to the definition. The one thing to remember about the random node, as I said before, is it changes every time. So I don't want to keep running this definition when I want to find specs. So what I've done is I've added a set name node to the end of this definition, and I've named it parawall. So when I run this definition, the object I want will have the name parawall, and I can use that name to analyze it. So let's run it. So let's just double check. We go to our wall. We see it's a generic solid and it has the name parawall. So now let's get some information about it. So we have our name node, parawall, and this first wrapper is has the get 3D info object info node, which will give me the 3 dimensions of the wall. So I'll use that as my original volume, and then the volume node does exactly what it says. It'll give us the new volume of the generic solid that we have input, and it'll also give us, this one will give us the surface area. And what I've created here is a wrapper that will take the value that we're given and a title and print it out onto our drawing. This is another node that Marissa made. I find I use it a lot in my definitions. So if I run this, we see these text boxes pop up. The original volume of the wall was 300 feet cubed. The new volume is 169 feet cubed, and the surface area is 929 feet squared. So these are just some very basic facts and data extractions that we can do using Marionette and on geometry. But we can also extract data using records. So if we go to another file, we can see that we have some polygons that were imported as GIS data. When you import shapefiles with GIS data into Vectorworks, the geometry comes in with records already attached. If we click on these polys, we see that they have a name, and we also see, when we click on data, that they have the demographics record attached to them. And they have these 4 different pieces of data all attached to the different polygons. So we can use this information to extract data from them and manipulate them if we want. So the first thing we can look at is we can create a color range based on values. So this is a network that will take 2 colors, whichever colors are put into these 2 sample boxes, and will create a gradient between them. So make this color. And now, when I run it, it'll look like this. So basically what it does is it takes a list of values and it converts them into a corresponding color value with this node, the remap domain node. This is a node that I created, although it can be made by wrapping a few nodes from the original library. But what it does is it takes a list of numbers, and then if you give it the list, a new max and a new min, it'll remap that list to that new range. So basically you can turn any set of values into a new type of value for something that you're going to use later on. So yeah, if you see, if I change the colors and run it again, it automatically updates. So now I can do the same thing to my map. I can get the values I want to display using a getRecord field node, and I can apply those values to my fill range. So a getRecord field node is in the library all the way down here in records and IFC. So what this node does is it takes the info from the record that was attached to the polygon. So if I give it the record name, demographics, and if I get the field name area, this will give me the field value. And sometimes when you're using this node, even if the field value you're looking for is written as a number, it sometimes gets seen as a string by Marionette. So I always put a float node after the field value to make sure I convert that to a floating number or a real number. And here are sample boxes on this definition. So now we have this definition set up so that the values will alter by area. So let's run it. And we see that every area gets a new color value based on where it is in the list. So I can easily change this to query a different part of the record. So instead of area, let's say I want to do population. So all I have to do is change that string name to population, and it'll give me the population value. If I run it again, you see that it's changed from what it was before. I can change colors. So another thing we can do is we can add labels to our map based on the record fields as well. So as you can see in this definition, we're using nodes from the text category. Text is, we treat it as an object, and basically it's a text box that would get printed out. So we can edit all the properties using these nodes. So I have to objects I want to use to set up my labels. So I'm using the same record, demographics, and the label field is I want the name, and I'm going to convert that name to a string. And then all of these nodes will be used to justify it how I want it to be justified. And here I can specify the font name just by typing in the name. And I can also specify the factor of the font size by using a remap domain node again. So this time I'm going to use area as my factor. And if I run this, we see the names pop up. So I can change, let's change this again to population and see how easy it is to edit our map and make it look exactly how we want it to look. So I can not only do this with maps, but I can also create graphs and other types of graphics with these same principles. So here I've created a pie chart with where we can see, if we look at the definition, we can see that the pie chart has many different variables dependent on the information in the records. The size of the slice is dependent upon the population. The radius of the slice is dependent upon the area. The fill of the slice is dependent upon the area. And the label, the factor, is the density. So this is what this would look like. But say we wanted to change one of those factors. So instead, we make the values of the pie chart the density. And so we can have a myriad of different possibilities from just doing some front-end work. We have all these graphics that can be created. And this same principle can be applied to schedules. Just as I'm getting information from the records of these polys, I could be getting the information from the records of windows in a drawing or walls inside a drawing. So, any questions? Are there any output nodes that can be used to display non-editable info, such as the results of mathematical operations in the OIP? Well, not necessarily in the OIP, but we did mention the print list node, the one I used here, and that can be used. So let's create a definition, exactly what you asked. Let's add some numbers. Let's add 578 to 3,246. If we get this print list node, This is in my custom category. You run it, and then we go to the origin, and we see that this is the number, the answer to the mathematical problem. Another question. When you input your data request, is there a drop-down list of the records available, or do you just have to know exactly what type? Well, the way records are set up in Vectorworks is whenever there's a record attached to an object, you see it pop up in the resource browser under record formats. And if you click on edit, you can see what all the field names are and what the default types of values are and the default values. And when you go to click on an object, you look at data, you see that the demographics record has been checked. There can be lots of different records within a document, but whichever one is checked will be the one that's applied to that object. So it is important to know what the names are and to copy them exactly as they are when you're using a get record field node, because you are going to have to use a string. Okay. We have a little time left, so let's go back to that conditional question and see if we can figure out what went wrong. So what I wanted to do was to make sure that none of these rectangles were more than 3 times, the height was never more than 3 times the width, or the width was never more than 3 times the height. So, first one, so I have the width times 3, and the height is the input here. So if the height is greater than 3 times the width, if that's true, then I'll, instead of using that height, I will use the width. And likewise, if the height, oh, okay, I see what I have to do. I have to use another greater node. So if 3 times the height is less than the width, then instead we'll be using 3 times the height versus using the width if it's false. So now, so this is what it looked like before, which was wrong. Let's run it again. So now we see that none of the rectangles are too wide or too tall. So as you can see that these can get rather tricky, but if you can think of it, you can probably do it in Marionette. We have one more question. Is there a way to programmatically get a list of all the fields in a record? There is. It would involve creating a wrapper node that would query each field and then output it as a list. It's something that you can build based on the definitions that we have here in this file. And I remember someone asked a question last webinar, how long did it take me to learn Marionette? Well, I knew how to use Grasshopper pretty well before I started using Marionette, and I think first time I opened up Marionette was in August, so I've only been using it for 6 months, but definitely having the experience of another graphical scripting program helped me learn it a lot. But it does show that I know it may look really confusing at first, but it's a very steep learning curve, and once you get the hang of it, the sky's the limit. So that concludes our webinar for today. We'll see you in 2 weeks for part 4 of our Marionette Monday series, February 22nd, 2016. If you have any questions, be sure to let us know at vectorworks.net/Marionette or #MarionetteMonday. And continue the fun at the Vectorworks Design Summit